Number 2 says, in 40 grams of iron 3 oxide, find the number of molecules and find the number of atoms of iron. Iron 3 oxide is Fe2O3. It has a molecular weight of 2 times 56 plus 3 times 16, which totals to 160. If I have the grams of iron 3 oxide, the only thing I can find from that is the moles of iron 3 oxide. Once I have the moles of iron 3 oxide, I can get the molecules by using its moles. And then once I have A, I'm able to get B. So I'm going to start with grams equals moles times molecular weight. We have 40 grams equals the moles times the molecular weight of 160. 40 divided by 160 is 0.25 moles. Get in the habit of labeling all of your answers here of Fe2O3. Now to finish A, I'm going to use the formula number equals moles times Avogadro's number. Whatever it is I plug in the moles of is what I get the number of. So if I plug in the moles of Fe2O3, I will get the number of Fe2O3 molecules. If I plugged in the moles of just Fe, I would get the number of Fe atoms. If I plugged in the moles of O, I would get the number of O atoms. So 0.25 times 6.02 times 10 to the 23rd equals 1.5 times 10 to the 23rd molecules. For part B, I'm going to base part B on part A. I know that in every molecule of Fe2O3, there's 2 irons. So if I had 10 molecules of Fe2O3, I would have 20 iron atoms. So if I know how many molecules, all I need to do is multiply by the subscript, by how many irons are in each one, to get the number of iron atoms. And when I multiply that 1.5 times 10 to the 23rd by 2, I'm going to get 3 times 10 to the 23rd atoms of Fe. So again, when you're going from part to whole, either with moles to moles or molecules to atoms, you simply need to multiply by the subscript.